Permaculture Principles, Designing Solutions. The permaculture principles intersect across many disciplines, and they can give us a flexible framework to create efficient, integrated site designs. The principles have the significant advantage that they can be applied to almost any area of study. Let's take a look at how the principles can help us make conscious design choices. This presentation will include many principles by multiple authors. It's important that you develop your own way of working with these principles that is best suited to your situation. Each designer will choose which principles they would like to focus on based on their own project or preference. Principles are considered tools in an evolving toolkit of design methods. Choose to work with principles that resonate with you and what you hope to achieve. Don't expect to be able to absorb all of the principles in one sitting. We'll continue to revisit the principles throughout this course. Bill Mollison, the co-founder of permaculture, developed a set of principles in the late 1970s after he had spent a number of years living in the Australian bush and learning the patterns of the landscape. Mollison discusses more than 15 principles in his books. Let's look at 4 of Mollison's core principles to get us started. One of Mollison's core principles is multiple functions, meaning that every element performs more than one function in the landscape. For example, the gumi plant improves soil fertility by fixing nitrogen in the soil and also produces a crop of edible berries that are packed with antioxidants and vitamin C. Bush clover, another nitrogen-fixing plant, also provides us with edible leaves, which can be eaten raw or cooked. Comfrey is a multifunctional plant that accumulates nutrients in a deep root system, is a nectar source for insects, and it's also used as a medicinal plant. The principle of redundancy states that each important need, in this case potable water, is supported by using multiple sources. Redundancy protects us in the event that one of our sources fails. For example, in order to have redundancy in our water supply, we would need more than one source of water. We may also need a way to store water for future use. Functional interconnection means that garden elements are placed in such a way that the products or waste of one system serves the needs of another. One example of this is setting aside a portion of a chicken run to grow forage crops for the chickens. Forage crops are plants that are grown specifically as food plants for chickens. The ground in the chicken run is prepared for planting by the chickens themselves as they scratch and manure the soil. The area is then sectioned off from the chickens and planted with forages such as wheat, oats, kale, turnips, mustard, or comfrey. After the forage crops have grown to full size, the chickens can be allowed access to the forage area. In this scenario, the waste products from the chickens serve as the fertility to grow the crops, and the crops provide the food for the chickens. After the chickens eat the forage, the cycle can be started once again. Relative location means that we site every element in relationship to another element so that they might beneficially interact. In this design, the chicken coop has been placed beside the greenhouse, the foraging areas, and the orchard. Keeping chickens inside the greenhouse in winter can raise the ambient temperature of the greenhouse due to the chickens' body heat. After fruit harvests, chickens can be run through the orchard to clean up any fallen fruit that may harbor pests or disease. As we create these systems, we begin to understand how elements placed together can interact for the mutual benefit of the system, and ultimately, these well-designed systems require less maintenance by humans. Take a moment now to consider which of these 4 core principles you might be currently using in your landscape. Pause the presentation and write down at least one example of how you are using one of the 4 core principles in your everyday life. David Holmgren, a student of Mollison's and the co-founder of permaculture, developed a set of 12 principles that he outlined in his book, Permaculture: Principles and Pathways Beyond Sustainability. Let's take a look at some examples of Holmgren's principles. Observe and interact is one of the key principles for designing a site. As we observe the site closely, we recognize patterns and processes in the landscape. These observations are the basis for some of our design solutions. In this way, the design emerges from our observations and analysis through the design process, instead of imposing a design upon the landscape. Observing and interacting allows you to find the story of your landscape. Look closer and examine the history of your land, the people that lived there long before you did, and the practices that shaped the land you see today. We most often catch and store energy in the forms of sunlight, water, wind, or nutrients. Ben Falk is the designer of the farm in the photo, and he shows us an elegant example of catching and storing energy in a series of ponds. He uses ponds to bring life back to the brittle terrain of the Whole Systems Research Farm in Vermont. As we will see, the way we design for water in the landscape will greatly influence our overall success. Using local renewable resources means finding out what is freely available at or near your site that you might utilize for various purposes. In this photo, students are mixing cob, a natural building material composed of sand, clay, straw, and water. Cob is similar to adobe and can be used to build benches, sheds, houses, and many more structures. The principle "produce no waste" reminds us that any surplus in the system may end up as pollution if it isn't managed properly. These surpluses take on a new value as we find ways to cycle them through our system and reimagine them to create more abundance. An example of this principle is the management of livestock manure. If it is managed properly, it can be a key element in building soil fertility. Patterns exist in nature for a reason, to enable the most efficient energy flow and response. The spiral pattern presents itself to us fully formed from a tiny strand of DNA to our own Milky Way galaxy. If we take this pattern and use it as a design solution, we come up with the herb spiral. The herb spiral is a microcosm of permaculture principles. It serves multiple functions by providing food, medicine, nectar, and aesthetic appeal. Each plant is placed in a relative location so that its needs for sun and water are met while reducing competition from other plants. Some herbs will prefer the sunny south side of the spiral, while others will produce better in the partly shaded northern side. The herb spiral can be built using local renewable resources, such as stones, logs, or found objects. The edges of two different ecosystems contain the greatest diversity because they offer the best of both worlds in terms of habitat. Edges of ponds are particularly productive. In Mexico, native people designed gardens called chinampas, which were constructed as garden peninsulas reaching out onto freshwater ponds or lakes. The chinampas were highly productive food systems. Let's pause to review Holmgren's principles. Please choose 3 of Holmgren's principles that resonate with you. Pause the presentation and write down one example of each principle that you've chosen. Let's take a look now at some of the attitudinal principles that can help us navigate challenges in our designs. Work with nature, not against it. Joel Salatin has taken this principle to heart at Polyface Farms in Virginia. Salatin works in cooperation with his livestock to accomplish pasture management, food production, and pest and disease control. His finely tuned system of rotational grazing utilizes one species after another to take advantage of the animal's natural behaviors and diet. For example, after his cows have moved out of an area, he waits a certain period of time until grubs hatch in the cow manure and grow into pupa. At that time, he runs the chickens through the pasture, and they eat all of the grubs before they can reach maturity and cause an insect problem. The chickens also spread and scratch the cow manure and mix it into the pasture effectively. See solutions inherent in problems. This photo shows a wick garden, a way to grow plants without soil. People living in urban areas may not have a patch of ground to grow a garden, but instead of seeing it as a problem, they have developed an array of creative solutions. The wick garden is made from a layer of carpet laid down over the pavement and lined with bricks. The 5-gallon bucket on the left of the photo is filled with a liquid fertilizer which soaks into the carpet, feeding the roots of plants. The wick garden can be mulched with found materials, including corn cobs, pine cones, or even aluminum cans. Here are some ways that you can make the least change for the greatest result. Start small and build from success. Begin in the most degraded areas, where the most site repair is needed. And then ask yourself, where in the system can I intervene that will give me the greatest results with the least amount of impact? Everything gardens, which means that everything interacts with and modifies its environment. Most of the time, this interaction provides valuable feedback to us as the observers. Here's my resident flock of wild turkeys who insisted on gardening with me and scratching out all of the straw mulch that I had placed into my garden beds. My plan for next year involves placing straw only in areas that I want the turkeys to go and scratch. Who knows, I might even be able to have them assist my chickens in clearing the land for planting. And I'll leave you with this quote by Bill Mollison. Though the problems of the world are increasingly complex, the solutions remain embarrassingly simple.